the electron configuration using sp and d orbitals if needed for an atom, okay, an element, and we'll use phosphorus because phosphorus has got a few electrons. What do we need to do? First of all, we need to find its symbol in the periodic table. It's capital P, and you can see that smallest number next to it is its atomic number. It's 15, which means it's got 15 protons, which means it's got 15 electrons. So we want to now use the set of rules we've got here to find us how to write out its electron configuration using the orbitals. Well, the first thing we can do is remember, let's start by doing it with electrons in boxes, okay? So we'll have some electrons, or sorry, not electrons, we'll have some orbitals first. We're going to start like this. So we've got here a 1s orbital, a 2s orbital, the 2p orbitals, well, there's actually 3 of those, and a 3s orbital, and then we've got some 3p orbitals, and there's 3 of them. So those are the orbitals we've got available. Now remember, each orbital can only hold 2 electrons. 2 electrons per orbital, and they're going to fill up in the lowest energy level available, okay, one at a time. So we've got 15 electrons, so the first electron can go here in the 1s orbital. That's the lowest energy. Remember, this way is going increasing energy. So we've got 1 electron in our first orbital. The second electron is going to go in the orbital of next lowest energy. Well, this orbital can fill with 2 electrons, so the electron's going to go in there. But each orbital may only hold 2 electrons, and they must have opposite spin. And we indicate the opposite spin by changing the direction of the arrowhead. So we've got 2 electrons here, both with opposite spin and both with equal energy. Our next electron will go into the next orbital of lowest energy, which is the 2s. So we put another electron here. That gives us 3. The 4th electron is going to go into the same orbital because it's got the same energy, but it must have, again, opposite spin. So we filled in 4 electrons now. Okay, now the 5th electron, again, following our rules here, is going to go into the orbital with next lowest energy, the Aufbau principle. Okay, so that electron's going to go in here. So we've got 5 electrons. Now we've got 3 orbitals at the p level. There's an x orbital, a y orbital, and a z orbital. They've all got exactly the same energy. If you have a number of orbitals at equal energy, they go one at a time into empty orbitals, keeping the electron spins the same. Hund's rule. Just like when you get on a bus and you pick a seat by yourself before you have to sit next to somebody else. Not very friendly. Anyway, so our next electron, our 6th electron, is going to go in here. It's going to go into an empty orbital, but with the same spin. our 7th electron does the same. So we've got 7 electrons, 8 left to go. Well, the next 3 are still going to go into the 2p orbital because that's the orbital available of lowest energy. But now again, according to the Pauli exclusion principle, they're going to have opposite spins. So there we go, there we go, there we go. So we've got 2, 4, 6, 8, 10 electrons so far, 5 remaining. Well, the next energy level, the next orbital of lowest energy is the 3s. So our next electron goes in there. And our next electron goes in there. So we've got 12 electrons. 3 left. Our 3 next electrons will go into the next orbital of lowest energy. That's the 3p. So our first electron goes in here. But again, when filling p orbitals, they go in individually before pairing up. Now we've got 15 electrons, so we've written out our electron configuration using electrons in boxes, and we can now write that out using SP notation. We've got 1s2, 2s2, 2p6, 3s2, and 3p3. Some might even show more detail by writing 1s2, 2s2, 2p6, 3s2, and then 3px1 and 3py1 and 3pz1. Voila.